Okay, so here's the bit of revision on algebra. Algebra is basically abstract, yep, but it takes all the stuff that you know about numbers and just makes it general. That's all it's ever doing. So adding, multiplying, that's basically all you're flicking between. So that's all we ever do, is we put it into brackets, take it out of brackets. Okay, because sometimes it's easier to think plus, sometimes it's easier to think times. So if I said to you 3 lots of 17, right, so 3 lots of 17, I could think of it as 3 lots of 10, that's this block here, 30. That's 3 lots of 10. Oops, missed. 3 lots of 10 and 3 lots of 7. And that's that one plus 21. Okay, and that's because I can actually write it like this. I can think of the 17 as 10 plus 7. 3 lots of 10, 3 lots of 7. 30 plus 21. I've gone from a multiply, 3 lots of this, to an add. And adding is really easy. Yeah? It doesn't have to be a 10. It could be a 5. So if I've got 3 lots of 5 plus 7, okay, so 3 lots of, this is actually 12, isn't it? 5 plus 7 is 12. And I could think of it as 3 lots of 5 plus 7. This isn't the smartest way to think of it. You'd actually go 3 lots of 10 and 3 lots of 2, wouldn't you? I mean, but I'm just trying to show you that it doesn't matter what numbers you use. So 3 lots of 5 is 15. 3 lots of 7 is still 21. So I get an answer of 36. And you knew 3 12s were 36 anyway. Okay? But what I'm trying to show you is, it doesn't matter what this piece is, it will always be 3 lots of it plus 21. So when I do x, it will be this will be 3 lots of x. So imagine if it was 20. Okay, so now I would have 3 lots of 20 plus 7, or 3 lots of 27. Right, 3 lots of 20 is 60. 3 lots of 7 is still 21. So it must be 81. Okay, so what I'm trying to show you is 3 times any number plus 7 is always 3x plus 21. This block never changed. The x did, that's the variable, but it was always 3 lots of that block plus 21. That's what we call expanding, getting rid of the brackets. So I've gone from a multiplication to an add. That's step 1. So the next bit is to do double digits, right? So here I've got a rectangle. It's not a square, it's a rectangle. This is 10 and this is 3. This is 10, this is 2. So this is 13 on each row, and I've got 13 12 times. Okay, so this block is 10 10s. This block is 10 3s, but it's also 3 10s. This block is 10 2s, but it's also 2 10s. This block is 3 2s, and it's also 2 3s. That one doesn't matter which way I put it, just leave it as 3 2s. So what I'm showing you is 13 times 12, and I'm breaking it up into an addition. So what actually happens is I've split it up, and I've said, okay, this first block is 10 times 10. So I've rewritten the 12 as 10 plus 2 and the 13 as 10 plus 3, and I'm going to multiply them. 10 times 10 is 100. 10 times 3 is this block here, 3 tens. That's the 30. 2 tens is this block down here, 20. And 2 times 3 is 6. That gives me a total of 156. So instead of doing 12 times 13, I've made it into an add. In this case, x is 10, okay? So here I've got 10 by 10. This is 3 lots of 10. This is 2 lots of 10 and 2 times 3. So this is actually x squared. 3 tens is 3x. Can you see that this word tens is like the x? And here I've got 2x. And I can't do anything with the 6. So what I've actually got is this picture here. So x times x is x squared. 3 times x is 3x. 2 times x is 2x. And 2 times 3 is 6. So when I do the brackets of x plus 3 times x plus 2, I get x squared plus 2x plus 3x plus 6. This 2x and 3x are like terms. 2 lots of x plus 3 lots of x is 5x. I can't do anything else with the other parts. So I'm left with x squared plus 5x plus 6. If I look at it here, there's my 5x, there's my x squared, there's my 6.